Hi everyone, today I'm going to present you a use case that shows how to create a FastAPI Python module created by Uvi. I presented the same use case and the same video previously that showed how to create a FastAPI application from a Python module, but I used pip as a package manager previously, and pip is interesting and usual in the Python ecosystem, but today we have other package managers in the Python community like Uvi, and I wanted to show the same use case with a real-life application, separation of concern in the code, and how to build and deploy my application with import, Python package, and so on. And then how to deploy this application locally with Uvi, and how to run it and deploy it locally in Docker because it's interesting. And at the end, we will show the same use case with a CI/CD pipeline with Cloud Build. I also created the same video with Martin Omander, a developer advocate in Google Cloud. I will show in the video description the video presented with Martin, but the video presented with Martin was with pip as package manager. Today, the advantage of Uvi is Uvi use Rust behind the scenes, and Uvi is really faster than pip, than poetry and pipenv, and that's why today I wanted to show end-to-end use case and application. And compared to my previous video, I will execute everything locally because I think it's interesting for developers, cloud engineers to test their applications locally before to deploy it in the cloud environment. And that's why, and I also really recommend for Python developers in cloud or outside of the cloud to use Uvi, because Uvi is really fast and really interesting in the Python ecosystem. I think it's good for the schema. For the CI/CD pipeline, I will show with Cloud Build how to build and publish the Docker image in Artifact Registry. That is a repo in a private repo in GCP. And I will also show how to use the Docker cache compared to my previous video in order to save time between my CI/CD pipelines. It's really efficient to do that. And at the end, I will execute all my application locally and in the cloud environment with my Cloud Run service. I will jump on the code. I created a dedicated project and repo for this use case. And I propose the same application than previously. My application is really easy because I have an HTTP post request for my Cloud Run service. I use FastAPI, and also I use Pydantic behind the scenes because FastAPI use Pydantic. Pydantic allows to apply some validators on my input object and output object. With typing, I have a more robust code. My endpoint will receive an HTTP request body, then retrieve some environment variables. After this, I will prepare the Python client and the GCS Python client. I read the raw data from GCS, and then apply some transformation and business rules in my application based on a functional programming style, like I showed previously in my previous videos. And at the end, I prepare the BigQuery configuration and I load the result to my BigQuery table. It's done and okay for my Python application. Then I will switch with UV, and I will explain how to manage my Python packages with UV. I have, for example, this file, pyproject.toml. This file will contain all my Python dependencies and packages. As I explained previously, I need to have a JCS client, a BigQuery client to read data and write to BigQuery. My application uses FastAPI and Uvicorn because Uvicorn uses the ASGI protocol and will deploy my web server and serve my application. My application then can be started with Uvicorn, with a command line, locally or in Docker, and also with Cloud Run. I need also to have other packages that allows me to apply my business rules and transformation in the code, like Dacit and tools. I also can perform some unit tests with PyTest. For UV, I have this pyproject.toml file, and then it's really easy for me to execute a command line with UV to install my Python packages. I have this command line UVsync. With UVsync, UV will install all my Python packages in a virtual environment. There is a detail here in my use case. I use DirEnv. DirEnv is a really interesting tool because when I will enter and load my project, I can enable some command lines and create some environment, initialize some environment variables. I can automate some things thanks to DirEnv. And for example, when I access to my root folder on my project, if my virtual environment doesn't exist, I can initialize my virtual environment with this command line, uvvenv. It will create this folder, .venv, and inside .venv, we have all my packages installed inside the virtual environment. Instead of do that manually with command lines, it's not good to do that because it's error prone to do that manually. I use it and enable it with DirEnv. Then with this command line virtualenv and passadd, I can enable my current virtual environment, and it's really perfect. I can show you that. For example, if I left my current folder, DirEnv unload my current virtual environment. If I apply which Python tree, we can see that the current Python version is my global Python, the Python global in my machine. If I again enter inside my folder and apply which Python tree, we can see that the Python version is the version inside my current virtual environment created by UV. It's automatic and really interesting. After to install all the Python packages in my by UV, UV generates a log file, and the log file is interesting because UV will create a hash for each install package. It's interesting to do that because if for any reason a release changes remotely in PyPy or in a private package, the UV lock will prevent to install our package natively, and it's a really good security for the management of our Python packages. There is also a detail. With UV, we can also install directly the Python versions in our machine. But in my example, I have several ecosystems. I have, for example, old projects with pipenv and poetry, and all my new projects use UV. That's why in my case, I continue to install all my Python versions by pipenv. That is another tool dedicated for the installation of Python version in my machine, because all the ecosystem can really easily use natively the Python versions installed by pipenv. But we could also have created the Python versions and install the Python versions in our machine directly by UV. Then we can also create a Python version file at the root of our project, and to tell to UV to use a specific Python version when it will create his virtual environment. But in this example, I directly uses my Python version set it by pipenv. It's good for the explanation of UV. After this, I will show my Docker file. My Docker file here will uses a multi-stage build because I want to optimize the size of my Docker image. My first stage use an official image for UV, Python 3 bookworm, Slim. I set some environment variables in my Docker file for UV and also the path of my current working directory. I set then my work dir. Then I copy my pipe project, toml and UV log file in my Docker file. And then I have this command line that will use the UV cache, and with this command line uvsync, as I showed locally, this command line will install all my Python packages in my Docker file, and this parameter -- no install project is sometimes interesting, because here I only need to install my Python packages, but I don't need to package a Python application directly with UV, because my application will be installed inside my Docker container, and that's why here I passed this parameter. After to install all the Python packages, I copy my current Python application inside my Docker file in the working directory, and my first stage is done. I used here the virtual environment natively created by UV here. I could also have not used a virtual environment, because in Docker I am in an ephemeral environment, but it's easier to let UV create his virtual environment. And to be honest, the virtual environment not use several big files. The size of files are really small, and no need to add more complexity in the code. We have our packages and some other little files. That's why I use simplicity for this example. For the multi-stage build, my final stage corresponds to Python Slim, because the Alpine doesn't work natively with FastAPI. And when I finish to install my Python packages, UV is not useful at the end in my container. And with multi-stage build, I will also keep the element from the final image, and no need to keep UV and other things in order to have a smaller Docker image, because it's better for security. I set my working directory, and with this command line I will retrieve the element from the previous stage and copy the working directory from the previous stage to the final stage. The working directory from the previous stage contains the application and also the Python packages, thanks to the .venv folder. I only need after to add in the current path the venv bin path, because my Python packages contains PyTest, Uvicorn, and so on, and I need to access to this element in my current Docker file and in the final stage. The latest element, I don't want to launch my application as a root user because it's not good for security, and that's why here with this command line I created a user that will execute my application, and it's better for security. I only need after to give the permission to this user in my working directory, set the current user, and at the end this user will launch the application. I have two latest command lines, an entry point that is my default command line, and additional command line and parameters with CMD. I access to my Python main file, and I can pass some parameters for Uvicorn, like the host and the port. I finished to explain the logic in my Docker file. It's really good, and I will start as I explained in my schema. I will start and deploy my application locally with Uvicorn because UV installed all the packages. In my shell, I can execute Uvicorn to deploy my application and serve my application. I have the URL here. I can access to my application locally. I will access it with /docs. Then I will, because FastAPI uses Swagger natively, I can in try it out pass my request body. My request body is here in my README file. I will pass my request body here and execute my HTTP post request and execute my application. I have the Ghost response status 200, and my data was loaded correctly in BigQuery and is really perfect. I will end the current Uvicorn application and execute it with Docker locally. For Docker, I use Docker buildx build because I have Docker desktop in my machine, and Docker desktop natively use Docker buildx. I only need to execute this command line, Docker buildx build, access to the Docker file, and pass the tag that is a path to artifact registry. But I don't push the image here, I only build the image. I execute my build, it's really perfect. I enabled the cache, and that's why here my build was really fast. And I need to be authenticated in GCP, and I will authenticate my current user to GCP and my local machine to GCP with application default credential. I created another previous video for that. I will share it with you because ADC allows to authenticate my local application to GCP with my current user and a short-lived token. It's good for the authentication. Then I will run my Docker application. And for Docker, I need to mount as volume the current gcloud configuration with the short-lived credential. For the Docker run, I execute it. It's perfect. And I will access to my application again. I go to my application /docs with the same principle. I will execute my application deployed by Docker locally with my endpoint and click on execute. Normally, I will have the good status. It's really perfect. And it's good for the Docker local. It's finished. And the latest part of this use case is the deployment in the Cloud Run service and the CI/CD part with Cloud Build. I prepared this pipeline and YAML file with the Cloud Build, as I explained in many videos. Cloud Build is a serverless tool in GCP for CI/CD pipelines. Before to explain the logic, I will execute the deployment of the Cloud Build job. I have this command line to execute it. To save time, I execute the deployment and go again in the file for the explanations. Cloud Build is based on container and base images and Docker in this example. I use this Docker base image. Then I have an entry point bash. And in my example, compared to my previous video on this topic, I use directly Docker BuildX to have a more convenient command line with Docker. With one command line, I can build and prepare the tag and push the image to artifact registry, and also uses the image cache. The image cache allows me to use the Docker cache between my different CI/CD pipelines and different executions. It's really great because no need to install again some Python packages if they didn't change previously. And that's why here I wanted to show with Cloud Build how to enable BuildX with this command line, driver Docker container. And then I have this command line that is similar to the command line executed locally. I pass the Docker file, the pass for the tag to artifact registry, the -- push to publish it to this private repo, and the image cache parameters with cache at the end of the repo. It's good for this explanation. And for the second step, I use the gcloud SDK Docker image. Some developers uses the slim image, but the stable has a less bigger image and less size than the slim image. That's why I use the stable image in this step. I then need to execute the command line to deploy my Cloud Run service. This command line need to have the Docker image build and published previously to artifact registry, the region. Here I have a not secure service for simplicity for this example. My application is public, but in another video I will show how to deploy the same application in a secure way and to use a proxy to test locally our application, and how to maybe use it with IAP for my next video. But here, for simplicity, I use a public API. I can pass also some environment variables, and it's good. My deployment with Cloud Build is finished. I will access to my Cloud Run service. I have a dedicated page in GCP to access to my service. My service is called Teamlink Service UV. Here I have access to the metric, the logs, and so on for my current service, and access to the URL. I copy my URL /with/docs and access to my Cloud Run application and public API. I will copy my request body here, and we try it out, execute my application in my Cloud Run service, and I think it will be good for the response. I have the good status, it's really perfect, and I think I finished to present my use case. I showed UV with the toml file, and also the execution locally with Uvicorn and UV, the execution locally with Docker, and the deployment with CI/CD pipelines, and the execution in my Cloud Run service. I am really happy to share my knowledge with you, and I hope you will learn some things with this use case. Please feel free to subscribe to my YouTube channel to help my work for the Google Cloud community, and see you soon for next videos. Bye bye.